Hello. Today, I'm going to be talking about one of the methods that we used to solve for the roots of an equation. In this case, it's going to be the bisection method that we learned about in our numerical methods class. This method is the simplest one of the bracketing methods that we discussed. It is considered a bracketing method because it consists of two initial guesses that surround the answer or the root of the function. And first, I want to discuss why this method works, what it consists of, and then follow up with an explanation of the MATLAB code that solves the function with this method. So, the bisection method basically comes from the observation that when a function is continuous, its root or its solution it's going to be found between a change of signs. Right here, you can see how the answer is found between a positive side of the equation and a negative side of the equation. So what this method does is that it creates a test in which the user or the engineer, whoever, takes a guess as to where the root might be and guesses two values, the lower value and the upper value. And then it conducts a test in which the function is evaluated at those guesses. And then if those two functions multiplied are less than zero, then it means that there's at least one root inside of those two x values. So that's the premise for the bisection method. It is a method that iterates, meaning that it happens over and over until the root is found. And yeah, so I'm gonna go ahead and talk about the MATLAB code here. So, like I mentioned, we have our inputs, which is the lower value of x, the upper value of x, the stopping criteria of the function, and the maximum number of iterations. Then this code changes the function that is used. In this case, I am using the function for the problem 8.3, section 8.3 of our book that talks about an electric circuit with some constants such as the inductance and the capacitance, as well as, and it's basically looking for the resistor needed for that circuit to be solved. So then the function is evaluated at the first guess here, and then we go ahead and conduct the test, which is basically just the midpoint formula. Then we go ahead and check if the function evaluated at that point times the function evaluated at the point of our first guess, so xr, is less than zero, then our answer is like closest to the upper value. Then if the test is greater than zero, our answer is closer to the lower value. So if our answer is equal to zero, then we know if the answer of the test is equal to zero, then we know that the root was found. I'm gonna go ahead and try this method out so you can see how it works. You click here, run, and then based on the book, it gives us the first value, like our first lower guess, which is going to be 0 ohms. Again, we are trying to see what resistor we need for the circuit to work. Then we guess our upper value, which is 400 ohms, a stopping criteria of 0.0001%, and then the maximum number of iterations here, I'm just going to guess 50, and then we click enter, and we should obtain our root here, which is pretty close to the value given on the book. Actually, it is the value given on the book, and that is how the bisection method works. Pretty cool, pretty easy, and yes.